For the rating control, we need to have 4 small cupcakes. We're going to use the cupcake image and scale it and repeat the image 4 times. You'll often want to rotate and scale your views and layers and contexts, and you do this with transformation matrices. A transformation matrix can hold position, scale and rotation information inside a matrix. In case you're thinking that these matrices look a bit daunting, the code for using them is quite simple. CG-Affine Transform has several initializers for position, scale and rotation. This transform code sets up the matrix illustrated. You may have used CG-Affine Transforms on views before. In the previous section, you transformed the timer pointer shape layer using a rotation transform. Transforms work well with auto layout, but once you've transformed a view, the view's frame property doesn't hold a useful value anymore. You can still use bounds and center, just not frame. Here's the code to rotate a view by 45 degrees. As usual, rotations are in radians, and pi divided by 4 is equivalent to 45 degrees. The second line of code rotates the view by a further 1 radian. So you use transforms on UI views, CA layers, and UI Bezier paths. Transforming views is really easy. You just change the UI view transform. Here I've concatenated 3 transforms on a views transform all at once. However, the order of the transform is important. The top transform rotates, then scales, then translates. The translate takes place after the rotate, so the translation direction is in the rotated direction. The bottom transform translates, then scales, and then rotates. Transforming a CG context is a little bit different. It has an internal transformation matrix called the CTM, which stands for the current transformation matrix. To rotate the context, you just rotate it by an angle. We're going to draw 4 scaled cupcakes into a view, so I'll demonstrate how transforming the context will work. This is a UI view with the context indicated in yellow. It won't actually be yellow, this is just for show. We'll be drawing into the context and transforming it inside the view's draw rect. We're going to have 4 cupcakes, so I'll scale the context to 1/4 of its size. Now I'll draw a cupcake image into the context. This drawing code will be just the same drawing code as we've used already. Now I'll translate the context across 1/4 of the view's width, and I'll draw a second cupcake. Because we're positioning the context before drawing, we don't have to change where we draw the cupcake. We're just drawing the cupcake to fill the whole scaled context. And then we repeat this translation and drawing a couple more times. And that's how we'll be drawing the cupcakes into the view. To start with, it may seem a little complex, but you'll soon get the hang of it.
At the end of the previous video, we had an upside-down cupcake mask, and nobody wants that. Before doing the clipping mask, we're going to turn the context upside down. We'll have to scale the context by -1 as well, but we also have to translate the context down by the height of the context. First, we'll scale the context by -1 in the y-axis. The context is now upside down, but it's disappeared off the screen, so we'll translate it down. So that's worked great, but there's still a problem though if I redraw this image at the end of the method and show you. There's actually 2 problems. The image is upside down because the context is currently upside down, and the context is also masked with a cupcake mask image. What we want to do after having drawn upside down with a mask, we want to restore the context to its original state. So before transforming the context, we'll save its state. And after doing the transform and the draw with the mask, we'll restore the state. So now the image draws properly. It's not upside down and it's not masked. We can check there's no clipping mask by filling the entire context instead of doing this draw. So there's no clipping mask there. Let's just get rid of that because we don't need that. You can see that we're almost at the 4 red cupcakes now. We want to scale the context down by 4 and translate the context 4 times, just as I showed you just now. Let's comment out most of the code and deal with cupcakes for the moment. First, we'll scale the context to be 1/4 of the size and draw the image then. And remove this from up here and place it after scaling. Well, that looks right, but we need 4 of them, so we'll have a for loop. This is now drawing the image 4 times, but they're all being drawn at point 0. We could do math on the point like this. And that works, but there's a better way of doing it. We could just keep drawing at point 0 and translate the context. Let's undo that. And that's the same result, but the code's a lot cleaner. So we have 4 cupcakes, but the context state is messed up. So every time you do a transform, it's a good idea to have a save and restore around it. And see how I've actually stacked those states. Now we want to mask the cupcake, but only dependent on the rating. If the rating is 0, we mask all of them. If the rating is 3, we only mask the right-hand one. So let's set up an IB inspectable rating property. And set the rating to 2 in the attributes inspector. Uncomment out the code we had before for the mask. We want to scale and translate this 4 times too, but because the context needs to be upside down when we draw the mask, it's a separate for loop. So that's the first one, and we'll put the drawing in a for loop after flipping the context upside down. And just as we did before, translate the context. And nothing's showing up because we clipped the context with a mask. So we'll put another save and restore state around that. And that's putting crosshatch on all the cupcakes, but we only want to put them on the right-hand cupcakes. So we'll add an if statement checking the rating and end the conditional before doing the drawing. And remember, we set the rating to 2, so we've got 2 cupcakes unmasked. And we'll check the attributes inspector, and that works as well. To make the control interactive in the app, we'll add a gesture when moving the view to the super view. This method will check whereabouts in the view the user tapped and set the rating dependent on that. Calculate 1/4 of the width and work out which quarter the touch landed in. That will result in 0 to 3, so we have to add 1 to that. And now add the gesture to the view. And build and run. And nothing's happening. The reason why is that we have to tell the view to redraw itself every time we touch it. If you remember, DrawRect is only called when the view needs redrawing, and just touching it doesn't trigger a redraw. But we can trigger that redraw whenever the rating value changes by calling setNeedsDisplay. setNeedsDisplay doesn't call draw itself, it just marks the view as needing a redraw, so that during the next draw loop, the view's layers delegate will call DrawRect. Let's build and run and test out our Cater rating control. Well, that control looks about ready to track down and rate some caterers.